Okay, I'm going to run through how we construct the hardware for the onboard race computer. So this is the total enclosure. I've taken the screws out already so we can open it, but just to have a quick look, it's got some vent holes at the top. So these two are for vents. This is for mounting on an aluminium bracket that comes out of my dash. And then underneath I've got two more vent holes so we get flow up and through the computer. I was a bit concerned about temperature actually because it's a black case. It's mounted pretty much in full sun through the windscreen. And apparently they do generate some heat, so the Raspberry Pi that is. So I would encourage you to put the vents in, but I haven't had a problem with it so far with this setup. You can see the button on the front, that's to change the display. It moves between the pages of the race computer. And then on the side we've got a reset button. You push it twice to shut down the unit, and then you can push it again and it will start again, restart. Otherwise it starts on power up. I have had a problem with it picking up the CAN bus signals, and I usually end up having to go through a cycle of pressing it twice, waiting for it to shut down, and then pressing it again to start again. I'm going to try and get to grips with that, but I've got a feeling it's to do with the power, the way that we're powering the box. So it may not be easy to resolve, and we may have to go through this this procedure to get the thing to start up correctly. The bottom socket here is for headphones, so you can set it so that it squeals at different pitches depending on the amount of brake pressure you're placing. When you've got your foot off the brake, it doesn't squeal, just to set your mind at rest on that. I've been experimenting with it to improve my brake profile. This socket was going to be used for a switch to mark the start of a race, and it's to do with the way the fuel calculations work. In the end, I didn't use that. I used a combination of the pit switch, pit speed indicator switch, and the button on the front. So if the pit speed indicator is switched on and I press the button on the front, it sets the start of the race. I'll cover that in another video regarding the actual way the machine, the way you use this. And then we have a bulkhead connector on this side. This carries the power, the pit speed indicator switch, and the CAN bus signals. So a pair for each of those. To create the vent holes and the hole in the side for the bulkhead connector, I used one of these step drill things. So the one for the vent, that's a 12mm hole, and the hole for the bulkhead connector is a 16mm hole. So you can get these pretty much anywhere. Very good, just take your time and obviously drill a pilot hole where you want it to go, and then use this to actually cut the hole. Now if we move inside the unit, let's just lay it down there. The main sort of intelligence of this thing is contained in these three boards. The bottom board is the display. The center board is the actual Raspberry Pi, and the top board is the CAN bus interface. You can see that this particular interface card has two CAN bus interfaces there and there, and this is where it takes in the power. Now, unlike the Raspberry Pi, which requires a 5-volt feed, 5-volt power supply, You can feed the CAN bus interface with 12 volts directly out of the car, and just down here there is a thing called a buck converter, which is a DC to DC converter, and it converts the voltages down to power not just the CAN bus card, but also it will power the Raspberry Pi itself and the display. Now, important thing about the display is you notice this ribbon cable. This is, I think it's a DSI cable. Should have looked this up before I started recording this, but this is a high-speed display interface cable. I did originally build it with a different sort of display that worked via the what's called the HAT GPIO interface, which are these pins all along here, but I found it to be too slow. Now, it could have been the display was slow, it could have been that the original Raspberry Pi I used, which was a Pi 2, was slow, but I decided to go for this setup with the DSI interface, and it works really well. It's great. Here we can see the back of the bulkhead connector, obviously, and the wires coming out of that, either going into the CAN bus or going into, where have we got? Yeah, this one here, and this one, the white and the black one, white and blue one, which are for the pit speed indicator. And then we've got the power ones going straight in. Now, this ribbon, this cable I've used here to plug directly onto the GPIO pins. What I did was, you'll see in the parts list, I bought some of this ribbon cable stuff. It was about that wide when I originally bought it, and I just tear off enough connectors that I need. You can easily split it down just by tearing it that way, and these connectors fit directly onto the top of the these pins, so they're ideal. They're a nice snug fit, they work really well, and then all I do is chop the ends off of it and then solder it onto a connector, or even solder it onto another wire like I've done here with the display switch. The audio is a bit tricky. Now, the problem is the audio interface is just in here, and originally I did think about drilling a hole through the top of the case, plugging it in and bringing it directly out the top, but I decided that wasn't going to work. So what I did was I bought a 90 degree 3.5mm connector. And if I just carefully take this off, you possibly can't see this, but basically I've had to use a really sharp knife and keep shaving it down until I got enough clearance to get the this part into there, so that this edge here clears the edge of the connector, and it just about does it. So that was a bit of a pain. A way around that is to solder some connectors directly onto the circuit board and bring those out onto the audio plug here, but I didn't go that route. I just used this cable. In fact, this was a male-to-male cable, and all I did was cut it and just use one end of it, and I've got the other end as a spare if I mess something up. So again, all these parts are on the parts list. You can see that the race start button isn't connected, although the wires are there and the socket is there. It's not connected. The lid, or the fascia, is a 3D printed lid. My one's got a bow in it, curved, not because I designed it that way, it's because my stupid printer keeps lifting on the edges, and I've tried hairspray and goodness knows what, and I've done another one just here, and unfortunately this one's flatter, but it's still, you can see just there, it's still got a bow in it. So that's a problem with my printer, not a problem with the design. The switch hole is quite tight. I've purposely done it that way on this one because I didn't use a nut on the back of the switch, so I've basically just screwed it into the plastic and it's holding really firm. You may need to shave this out a little bit with a needle file if it's too tight. because I tried this one that I printed recently, and so if I get one of the button switches and I put that in there, I haven't taken the nut off the back, but it's actually really tight. Can't really see that, can you? There you go. It doesn't quite go in. I can just about screw it in, but it's very tight, so it's probably going to need shaving out. Full disclosure, actually, this one, I designed the hole in here. When I first built this, I wasn't going to have this button, and so this one here, I drilled it. I used a step drill to drill into the existing fascia. The other thing you'll notice is this USB dongle just here. This goes with this mini keyboard. When you're setting the thing up, the best thing to do is to power it up and then just use, you know, a terminal emulator like Putty on Windows, or I'm sure there's, well, on Linux it's just terminal, isn't it? And whatever there is on Mac OS. But you best just telnetting or SSHing into it and then setting it up as you need. But once it's in the car, because you may want to fiddle with some of the configuration parameters, I wanted a keyboard, and so I've got this one. Again, it's all on the parts list on my blog page. These small aluminium things here, I've detailed those in the parts list. It's just a 1.5mm aluminium cut into small strips and then a couple of holes drilled, and these are 1.7mm by M1.7 by 8mm screws. The holes are already preformed into the 3D print, so you should be able to just screw them straight in. They do actually hold, I think you can see that just under there, they do press down on some posts that are on the corners of the display, but the display is also held in, I think you can see it just in there, with some double-sided tape. So I cut some very small strips of double-sided tape, and you can see one of them on each edge, and it really has held it firm, so you can press this to your heart's content and it doesn't move. So that's all good. The only other thing I should tell you is that the lid, because I'm no I'm no expert with CAD drawing or Fusion. I used Fusion 360 to draw this. I didn't put in these semicircular channels, which would be needed because there's a ridge that goes round this box. It goes round here and then goes along here. So rather than try and, I did try, I fought trying to get this right, but I couldn't get it right. So in the end, what I did was I ground off the corners with a Dremel, but you could do it with a file. All you need to do is just file it flat so that it doesn't have the radiused ridge bit in each corner. And probably the final thing I should tell you is that if you're going to use this box, sometimes there are preformed standoffs and strengthening ribs in the box that get in your way, and you may have to use, again, a Dremel or something to grind those away and to give yourself more space. I don't think there's anything to tell you about the actual construction of this piece, because this is just a standard Raspberry Pi stack, you know, and it's all stacked on these GPIO pins, one of which I've pulled off. I'll have to check which one that goes to. But yeah, it's all stacked on those GPIO pins. All of the posts and the spacers and everything comes with the different components that you buy, whether you're buying the display, the Raspberry Pi, or the can hat. It'll have all these screws and posts, so you haven't got any additional things to buy in that respect. Okay, well, I hope you found that useful. If you have any problems, just drop me a note. You'll find me, probably best to find me on Facebook or whatever. Drop me a note and I'll try and help you as best I can.